Hello everyone. All right, this is the sixth and final lecture video on the rules of differentiation. We're going to be discussing the general power rule and working some examples concerning the general power rule. It's another form that involves the chain rule. And then once this video is complete, you'll have all the material, all the lecture material, all the lectures you need to finish the homework concerning differentiation. Okay, so let's get started. And before I introduce the general power rule, I want to review the power rule from our first video, right, which was our second basic rule of differentiation we learned. Okay? If I have a function g of x that's equal to x to the nth power, right, where n is some real number, it's called a power function. Okay? Then we know that the derivative g of x, denoted with as g prime of x, is equal to n times x to the n minus 1 power. Right? We just bring the exponent n down in front of the x, and we subtract 1 from it. Okay? Well, the general power rule, okay, deals with the situation where the x here is replaced with an algebraic expression involving x. So it's no longer just x here. Okay? It's like a function of x. So in the general power rule, I have the function h of x. And instead of h of x just being equal to x to the nth power, it's equal to some algebraic expression involving x raised to the nth power. Right? So it's a function of x raised to the nth power. Well, what's the derivative h of x then? Right? Denoted h prime of x. Right? You might think, well, you just bring the n down like we did up here with the power rule. You just bring the n down in front of f of x and then subtract 1 from the exponent. And if that's all you did, you'd be half right. But there's one additional step with the general power rule. When the x up here is replaced with a function of x, right, the first step is, when you find the derivative, the first step is to bring the exponent n down front and then subtract 1 from the exponent. But then you have to multiply all that by the derivative of f of x, this algebraic expression involving x. And so that's that additional step from the chain rule that involves that multiplication. Okay? So let's work some examples to demonstrate the chain rule. In our first example, from your note packet, and I'm on page 23 in your note packet. In the first example, we have f of x is equal to 3x plus pi raised to the 4th power. Okay? So we know how to differentiate x to the 4th power. But now instead of just x to the 4th power, we have 3x plus pi raised to the 4th power. Okay? And so this inside the parentheses, right, is the algebraic expression involving x. And f of x now, right, is on the left-hand side, so its role has changed in this example. It's now on the left-hand side. Well, the derivative of f of x, denoted f prime of x, just like we would with the power rule, we take the exponent 4 and we bring it down front. And then we subtract 1 from the exponent, right? So we have 4 minus 1 in the exponent. But because this in parentheses is not just x, we have to multiply all this by the derivative of what's inside the parentheses up here. And the derivative of 3x is 3, and pi, you know, is a constant, 3.141, and the derivative of a constant is 0. So the derivative 3x plus pi is just 3. And so if we clean this up a little bit, 4 times 3 is 12. And 4 minus 1 in the exponent is equal to 3. And we're done. So the derivative of f of x equals 3x plus pi to the 4th just simplifies to 12 times 3x plus pi to the 3rd power. Okay? So where did this 3 here come from? It's the derivative of what's inside parentheses, the 3x plus pi. That's where that 3 came from. In the next example, we have y is equal to the cubed root of x squared minus 7x. Well, you know, before we can differentiate this, right, you got to deal with this cubed root, okay? And you know, whenever you take the cube root of something, that's the same as raising that something to the 1/3 power, right? So earlier this semester we've already reviewed that the cube root of x is x to the 1/3 power. Well, here we're taking the cube root of x squared minus 7x. So this is the same as x squared minus 7x raised to the 1/3 power. And now in differentiating this, okay, we have to apply the chain rule. Right, the derivative of y we denote with y prime. I'm going to emphasize that's y prime. And on the right hand side, right, using the general power rule, we bring the exponent 1/3 down in front of the left parenthesis. And then we subtract 1 from the exponent. 1/3 minus 1 is minus 2/3. And then we're not done. We have to multiply all this by the derivative of what's inside the parentheses here. And derivative x squared is 2x. And the derivative of minus 7x is minus 7. And now we're done. This is the derivative of this function of above. Y equals the cube root of x squared minus 7x. And again, this in parentheses here, right, is the derivative of what's under the radical x squared minus 7x. It's not just, if this was just x to the 1/3, right, we wouldn't have to have this extra step. But because we have an expression, an algebraic expression involving x raised to the 1/3, we have that extra step. All right, in the next example, we have g of x equal to e, the quantity e, raised to the x to the 5th minus 2 power, plus 9x, and that sum raised to 18th power. So we have g of x is equal to e raised to the x to the 5th minus 2 power plus 9x, and that sum of those two terms raised to the 18th power. So what's the derivative? Of g of x? Well, the derivative of g of x denoted g prime of x, right? Using the general power rule, we got to bring the 18 down in front of the parentheses, left parentheses. And then subtract 1 from the exponent, right? Just like we did with the power rule. But because this is an algebraic expression involving x, we got to multiply all this by the derivative of what's inside the parentheses, which is kind of complicated. Good review. The derivative of e to the x to the 5th minus 2 is itself and then we have to apply the chain rule in the derivative of e to the x to the 5th minus 2, right? Because this is not just e to the x. And so the derivative of this exponent, x to the 5th minus 2, the derivative of x to the 5th is 5x to the 4th, and the derivative of the constant minus 2 is 0. So we have times 5x to the 4th. So that's the derivative of e to the x to the 5th minus 2. And then we add to that the derivative of 9x, and the derivative of 9x is just 9. And we're done. This in parentheses here, okay, is the derivative of e to the x to the 5th minus 2 plus 9x. And so we've successfully have found the derivative of our original function g of x by using the general power rule. In the next example, we have h of x is equal to, in parentheses, the natural log of x minus 3x plus 1, and all that is raised to the 100th power. So instead of x to the 100th power, we have this in parentheses raised to the 100th power. So the derivative of h of x denoted h prime of x is equal to, right, using the general power rule, we bring the exponent 100 down in front of the left parenthesis. And then we subtract 1 from the exponent, just like we would with the power rule. But because this isn't just x in the parentheses, we have to multiply this by the derivative of what's inside the parentheses. We've got 3 terms. We can differentiate term by term. The derivative of the natural log of x is 1 over x. The derivative of minus 3x is minus 3. And the derivative of the constant plus 1, you know, is equal to 0. Now we're done. This is the derivative of this function up here, h of x, using the general power rule. And then lastly, we have the last example that we have to work is y is equal to the square root of x to the 5th plus 4 to the x minus 3. And you know that before we can differentiate this, right, we got to deal with the square root. And from earlier in the semester, you know, like square root of x is equal to x raised to the 1/2 power, right? So all this under the radical, we got to raise to the 1/2 power, so we can differentiate it using the general power rule. So when we do that, we have x to the 5th plus 4 to the x minus 3, right? That's what's under the radical, all raised to the 1/2 power. And now we can apply the general power rule, right, to this expression on the right-hand side. The derivative of y, which we denote with y prime, is equal to the derivative of the right-hand side. And when we differentiate the right-hand side using the general power rule, we bring the exponent 1/2 down in front of the left parenthesis. And then we subtract 1 from the exponent. 1/2 minus 1 is minus 1/2. And then we have to multiply all this by the derivative of what's inside the parentheses here, or what's under the radical. Well, derivative of x to the 5th by the power rule, basic rule 2, is equal to derivative of x to the 5th is 5x to the 4th. And we add to that the derivative 4 to the x. Well, 4 to the x is an exponential, right? It's not a power function, it's an exponential. And so the derivative 4 to the x is the natural log of 4 times the exponential 4 to the x. And the derivative of minus 3, the constant is 0. So again, finding this derivative, we bring the 1/2 down in front of the left parenthesis, and then we subtract 1 from the exponent. And now we got to multiply that by the derivative of what's inside the parentheses. Well, the derivative of x to the 5th is 5x to the 4th, and the derivative 4 to the x is the natural log of 4 times 4 to the x, because this is an exponential. And the derivative of the constant minus 3 is 0. And we're done. That in the box is the derivative of this function right here. So class, that concludes the lecture on the general power rule. You now have all my lectures on video for the rules of differentiation. Okay, so you can watch the videos and complete the homework on differentiation in WebAssign. Okay. If you have any questions, don't hesitate to email me. Okay. Have a good night.